Hello, Mike here, and welcome to this live stream again for Let's Build Something Machine Learning. I am joined, as ever, by my fellow co-host of this stream, Safdar from Chicago, United States. Hello, how are you going?
Hi,
Hello, how's your week been?
it's good. It's good. And today we have a weekend starting. So I am excited to have this wonderful session, learn more, and start my weekend on a very, with a lot of information on my head.
Yeah, well, it sounds like you've had a tough week, but we can talk more about that maybe as we go along. Okay, so yeah, just let's everybody catch up with where we're at here. We have this live session is all about building a machine learning project from end to end. We started a couple of weeks ago by just dipping our toes into what machine learning was, and last week we put together an environment where hopefully we can use that environment to help us build a machine learning solution. Maybe what I can do is just have a little bit of a recap of where we're at and talk a little bit about the project that we're going to be building and what the opportunities are. In the meantime, hopefully everybody's piling into the live stream. And so please, as you arrive in the live stream, let us know you're there, say hello, let us know whereabouts in the world you are from, so that we can just shout out and say hello. What I'll do is I'll just throw the diagram up on screen. Here we go, and here we go, and here we go. And so we'll just start to draw what the solution is, what the project is that we're in the process of building. This is an image which I drew multiple times in the previous live streams. And I mentioned, yes, we are live, and that means that you do have an opportunity to join us in this stream, ask questions as we go along, ask questions about the machine learning projects you're working on, and we'll endeavor to answer those. However, if you can't watch live, then well, obviously you're not watching live now and you're watching the recording. So you can also post messages to us on social media in LinkedIn and the like, and we'll be able to answer your questions there as well. And so here's a mobile phone. It's a mobile centric machine learning application that we're building. And the idea is that we're going to have an object. I'm going to draw a different object this week. There's my cup of tea. It's always important when you're doing machine learning, in my humble opinion, to have a cup of tea. It is a genuine cup of tea and it's genuinely hot. Anyway, so we have the cup of tea there. In this particular case, doesn't have to be that this project's to do with that. And the idea is that we're going to take a photograph of the thing that we have, so it ends up on the screen of our device. Doesn't have to be a phone, but if you've got a phone, it works best just because the camera is integrated with it. It will then send that image off into our AWS machine learning solution that we're going to build. It'll send back some information and say to the phone or the device that we're using what the object is. So there's a bunch of stuff that we've got to do here. There's a bunch of data that we've got to collect. There's data that we've got to format together. There's also the machine learning solution that we've got to build and the integration piece. And then finally, I guess we've also got this application that we've got to have running on the phone as well. Now, it's not going to be an in-depth development kind of session. We're not going to necessarily, well, we are going to code this all. We're not going to focus on a lot of what's on the phone. We're mostly focusing on this machine learning section here. And importantly for us, that's going to also include all of this data preparation side of things here as well. So let me jump back to Safdar. Safdar, how have we got? We got people joining the live stream, which is great. Anybody saying where they're from?
Yes, we have Paxton, and he is saying hi from Seattle.
Hi from Seattle. Awesome to say hi to Paxton. So we have got the ability to throw your comments up on the screen. For whatever reason, I'm going to have to click the buttons myself because we've had some slight problem technically. I think every stream so far we've had some kind of subtle technical problem, but whatever. And that is fine. So right now I'm just going to find that I need to log into my AWS console, and I'm going to do that off camera so that not everybody sees how I authenticate.
We have Michael from Pittsburgh.
Pittsburgh,
Hi,
awesome,
Michael.
awesome, great to see you. Happy Friday. Hope you've had a good week. So Safdar, you mentioned at the end of last session that you were going to go away for Labor Day, I think. Did you manage to get that?
Yes, I went actually around. We have a place near Chicago. It's like a little hilly area. It's called Galena. So it's a city, wonderful city, and you can have views of Mississippi River from there, right? So we had a nice I had a nice family time actually.
Awesome driving, doing the road trip. So
Yes.
awesome stuff. So all good. Now, as we're waiting for people to join as well, I am in the process of, as I said, trying to log into my AWS account, which we'll just keep going in the background in just a moment. What I also want to point out is that I've been uploading the code from these sessions into GitHub. So let's just have a quick look at where we're doing that. Let's put that up onto screen, and so many buttons to press after. I can't tell you, there's so many buttons to press. Where is even my mouse gone? Okay, there we go. So here we've got this GitHub repository where we're putting up all of the code that we are building. And last week we put together a Jupyter notebook with some code in, and we had a go at training up a model. That model had the NIST handwritten character data set, I think, in it. So let's just take a quick look at that here. Actually, in GitHub, if you click on a Jupyter notebook that's in there, it'll actually show you a rendering of that. So it doesn't just show you the code. But we are using Sagemaker notebooks, and it says, oops, something went wrong. Reload. What's going on? That's what happens when you do a live stream. So things go wrong. But it's in there somewhere. I think we just might need to have a major refresh of my browser, because at the moment it's struggling to log into AWS and it's struggling here. Okay, here we go. So this is the notebook that we put together last time, or complete with typo. And I was very grateful for those people that sent me photographs of them watching. I saw these pictures of people who are watching the live stream on their couches with their dogs. And this was big on the screen, complete with typo. But anyway, so this is what we put together. And this is up inside of that GitHub repository. It'll have the images in here somewhere as well that we started to play around with these things. So this is our GitHub environment. Now I'm still trying to log into my AWS environment. I would encourage you to do the same. I'm going to try opening a completely new tab. Isn't this exciting? So we'll just come back to our main view while I'm doing that. What's going on here, Safdar? Why can't I log into AWS? Because it is kind of critical to be able to do the project that we're building today. Who knows? I'm putting you on the spot. We have more people joining us in the live stream. Thank you for that. Right. Do say hello as you pop in. Very keen to say hello and find out where you're from. Here's another comment up here. And just to show that we can put your questions up so that we can answer them as we start. Super exciting to see that this isn't working at all. All right, whilst I completely restart the browser that I'm using and hoping that is enough, let's talk a little bit more about what we're going to be doing today. Because essentially what we're doing is we're building up this machine learning project end to end. And we are going to, in this session, be talking very much about data, because data, of course, is central to everything machine learning. And we're going to be talking about how we put the data set together to help us train the solution that we're trying to do. So obviously talking at the same time as trying to do 1,000,001 other things. So let's talk about the problem space that we're going to try and solve, the project that we're going to build. What we wanted to do was we wanted to build this image classification. We've seen the diagram that I showed you before was with the mobile phone, taking images of things. And what I wanted to make sure is that, what was this? Oh yes, please tell us where you're logging in from. That's just from you, Safdar. I won't throw that on screen. So what we're trying to do here is I want to put together this solution with a set of images that we all have access to. And so this is essentially what I'm going to do. This is what I'm suggesting. So we actually had, during the stream last week, we had several suggestions about what we could do. And one was from Elijah Kali, I think he's from Kenya. And if you are watching now, or if you come on board later, then let us know. And they suggested that they wanted to do a tree classification, so they could have different trees. That's awesome. It is also slightly complex, and there's quite a lot to it. And I want to start simpler. So what I'm going to suggest we do is symbol recognition. And first of all, we're going to look at a symbol data set that I've put together somewhat for us, and we're going to build up throughout the rest of this session, if I can log into AWS. And so what I've got is 3 symbols, and I've got a PDF of that actually inside of that GitHub repository, so that we are all working from the same thing. And so the first symbol is in honor of Elijah, who came up with the idea, is the tree. Yes, it's super simple, but there we go, it's the tree. We also had suggestions in there because it's also always suggested when we're doing this kind of thing, and that's the hot dogs. So there's the hot dog. So we've got a tree and a hot dog, and because I'm involved in this, I've also got the cup of tea. Yes. So we've got these 3 symbols. So what we're going to do is we're going to create a data set which is capable of recognizing these 3 symbols. That's the plan. That's what we've got in place here. And so I've done, and the reason why I'm doing that is because you can print these out and you can create your own data set from these. We're all working on the same thing. However, if you have an idea of a data set that you'd like to put together, shout out, let us know what you're going to do. We'll support you as much as we can in you creating that data set. So happy days. I am actually now looking at a login console for AWS. That obviously something my end, wouldn't possibly be anything else anywhere else. Open my password. I can't speak when I'm typing in a password because otherwise I will get it wrong. And let me just go and we're getting there. We're getting there, folks. We're getting there. And almost there, and almost there, and there, and there. Okay. Excellent. Now I can switch back to that screen. Sorry about that. I was,
So we have
yeah, go ahead.
we have couple of folks from Nigeria. Onordino is from Nigerian Delta State, and Bol Watif is from Lagos, Nigeria.
Excellent. And thank you so much for coming along. Awesome. What time is it in Nigeria? Please tell us what time it is there. I got a feeling like it's kind of late. So I really do appreciate you being online at this time of night. Maybe you can tell us what time it is. Obviously, we could do a Google search, but it's easier to ask you. All right, let me just go in here and in there. Okay. It's all working again. Breathe a sigh of relief, Safdar. It's all working again. Whilst I load this up, excellent. So we can now see it's loading into my AWS account. There's my account number on screen. Fantastic. Sure, that doesn't matter. And we're getting there slowly. And the idea is that I'm going to now build up my or get back into the Jupyter Notebook environment that we had. So I'm just going to do that now. We went through this last session, was to get a Jupyter Notebook environment so that we've got a coding environment that we're working in. So I'm going to go to Amazon SageMaker, and I'm going to go to Notebook, and I'm going to go to Notebook Instances, which is just underneath me there as you're looking on the screen. And here you can see the Notebook server that I set up in the last session. Let's click Start on that. And hopefully now everything's going to run a little bit more smoothly. Now, as this starts up, it will take a couple of minutes. Let's talk a little bit more about that data set that I had as everything's starting to settle down. So let's just hop over to GitHub, where I should already be logged in, which I am, so thank you for that, and into the actual GitHub repo here. So there is a link to this GitHub repository underneath this live stream, and there will also be a link every time we have a new video. I'll post a link into there as well. And so we have here, it is 1:45 in the morning over in Nigeria. So I'm very, very grateful to you being with us. Thank you very much. Welcome, and I hope you get value from this live stream. Okay, so yeah, go ahead.
Sorry, we have Rui from Portugal.
Excellent. I missed that one. Oh, that's just come in. Just there we go. I'm very, very appreciative of all of you coming from a similar kind of time zone area. That's cool. I'm hoping this is going to be relaxing on your way into your deep evening. Who has also said it's almost 1 a.m. there as well, so similar time zone, I guess. And Paxton, yeah, it doesn't count. 5 p.m. That's fine. You kudos for you being here, Paxton. Thank you. Producer of the show, friend of the show, Paxton. Thank you so much. All right, so we have got our GitHub repository here. What I wanted to show you is I wanted to show you the extra stuff that we have inside of this repository now. So we have the original notebook. There's this README. I'm going to add to this README every time we have a new episode, and I'll put down a link to the specifics, and the video actually will be in here. But what we now have is this new folder here, which is LBS, which is Let's Build Something, episode 2. And inside of there, we got some imagery data. In addition to that, we've also got this PDF file here. And this PDF file is, as I was talking about before, camera, buttons. Camera, buttons. That is the PDF file, which has all of these images in here. So you all get to build along with this. This is basically what I'm saying. So the PDF file is there. You can go and print those out and start to build up your own data set if you want to. However, I have also taken some images that we can use. All right, let's go back to SageMaker and see how well we're doing here. Basically, what I'm waiting is for this to come up and say it's in service, which it's now saying, thankfully. So I'm going to go along and go to Open Jupyter, and that's going to send us into our Jupyter Notebook environment. We did all of this in the previous session, and you can see here my notebook looks pretty much exactly as it did at the end of the last session. What I want to do is I want to pull in all of the data from the GitHub repository into this running notebook environment. So I'm going to do that using the command line inside of this environment. So let me just go here to new, and this is where we went to create a new notebook previously. But what we're going to do is we're going to create a new, scroll right down to the bottom, a new terminal. So hopefully you can see that right down the bottom there, new terminal. That'll open up a new tab, which has essentially got command line to our notebook instance. And it's just probably the easiest way, I think, to be able to grab all of that stuff from GitHub into our running Jupyter Notebook environment. So this is just bash terminal. If I do ls, then I get the listing of where I'm at. And you'll notice in here that there are a couple of different folders in here. There's one called SageMaker, and it's the SageMaker folder, which is actually the root of where we see when we go into this tab here. So this folder that we're looking at here is the SageMaker folder. So if I change directory into SageMaker and enter on that, if I do an ls there, then I can see that notebook that I had, which is in the root folder of our notebook. And so if from here we do a git clone, we're going to get all those files through. So let's talk through how we can do that. I'll go back over to GitHub. I'm going to go back to the top level. So we're going to end up with a little bit of duplication here, but that's fine. We're going to drop down this code list here. I'm just going to select HTTPS, highlight all of this or copy it. So we're copying this link. And this link here is the link that we need to be able to clone our repository. So I've gone to this code menu here, and I've gone and copied this with HTTPS selected. And I'm going to use that now to grab all of that code and bring it into my SageMaker Notebook environment. So back onto that command line. With that in my clipboard, I can say git clone, so git space clone, then paste that link in. And that's all I have to do. Press enter on that. And if everybody's smiling on me and I did the right thing, then it's going to grab that info, which it has done, which I'm glad to see. So if I go back over to my home tab now, you'll see that a Let's Build Something folder comes in. So this notebook that we built before, that's still there. And if you've done some changes and edits in that, that's still there. But we've got this Let's Build Something Live folder. If I go into there, I now have my clone of everything that was in GitHub. So we've got that, and we can play around with that inside of this session. All right, so let's navigate into the LBS Ep2. So this is the episode 2 data. And here we have all of that data from GitHub that we're going to use. All right, so that's just that sort of like first step. And if you need time to catch up with that, then you can, because we're now going to talk about the way that we collect data in order to do this machine learning problem that we're working on. And this is really the guts of what I wanted to talk about in this session today. This is, I believe, one of the most important and most fundamental things that you can know about machine learning, especially supervised machine learning, where we've got a data set, a labeled data set that we can use to train up a machine learning model. I have this, I'm just going to bring Safdar back into this for a second. Safdar, I have this thing that I say, and I say it slightly tongue in cheek, but I say machine learning is easy. And I don't know whether you would agree with me on that point, that machine learning is easy, but I think machine learning is easy. But I think data is the hard part. So we have a whole bunch of algorithms and stuff already done for us that we can use. Convolutional neural networks, recurrent neural networks, all of these things are already being developed. We have to use them, and the way we use them is through data. Would you agree with me on that?
Yes, Mike, I think this is a very nice point because for any machine learning, data and labeled data, like
Mm,
supervised learning, labeled data is the key. The more complete and accurate the data is, the more accurate your model will learn actually, right? So just I
absolutely.
would like to add one thing on this, on the data, that uh, having data, lots of data is important, but having a balanced data sample set is very important. Balanced sample set data means like for example, if you're predicting class A or class B, and you have class A, class B, class C, or different type of records. Exactly. So you should have enough samples of these, and you should have balanced sample of these. It shouldn't be like that one sample has like 80% of the records and the other two samples have 20% of the records. Then your model will be something we call biased actually. So I agree with you that data is extremely important, and this is the only part. Machine learning is easy. I think you said that right, spot on, and I cannot agree more on that.
That's right. No, thank you for that. And I want to drill down into what you've just said there as well about what's really important to get from your data set. Balance is really important. And I like to think of this in a certain way. I think this helps to think of an algorithm that's training as a student. Let me show you what I mean by this. So if you think about a machine learning, well, let's look at the actual machine learning process, I guess. You take, just to make sure we're on the same page here, we take a data set, and that data set is labeled or otherwise. In this case of a supervised machine learning problem, it's labeled. We then move that into, or we bring that into a training process. And this training process basically is going to be linked to an algorithm. I'm going to say algo because I don't want to spell algorithm by hand. So we have this training process, and that training process spits out a model. Okay, and so that's essentially the path that we're following. Once we've got that model, we can then go and use that for making inference, and we can use that for making predictions about new stuff. But this is how we build up. This is how we get to that point. And so I think that it's really important. I think it's really useful to think of this in terms of people. I really genuinely think this. If you think about a student and you think about the algorithm, essentially, the algorithm up here is our student. I've written that in blue. Can you see that? Yes, you can. Let's draw a picture of our student. Here is our student, and they are happy. They're not particularly happy with the way I've drawn them, but other than that, they are happy. Okay, so this student is starting out their day. They're going to go to a school. Here's our school. And the student has a bunch of things with them, right? So they got their lunch, they got their notebooks, they got their pencils and everything. They're happy, they're ready to learn. And the algorithm, the training, and the hyperparameters and stuff that we'll talk about, that all goes into that. But if the student doesn't have any data, in other words, it doesn't have any, I don't know, textbooks, it doesn't have an actual teacher, then it's never going to learn anything. It can sit in school all day long and never learn anything. And I want you to visualize this student. This student's going to be with you for the rest of your machine learning career. This student here, when it starts out the day, it knows nothing at all about what it is you're trying to teach it. So ultimately here, I guess the model, I don't know, what is that? That's the student graduating or something? Can we draw a graduating student? I don't know. Hopefully that makes sense. So we want to get to this point where the student knows what they're doing. At the beginning of the day, the student knows absolutely nothing. And it's important to have that in mind. And in machine learning terms, the machine learning algorithm, actually, most cases is, and the model, when it's training, is initiated with random data. So in other words, it has nothing in its head at all. And so the only thing it's going to learn about the data set that we provide it is the data set itself. And this is what Safdar was saying just there. The only thing it'll know about the domain, about the topic, about these symbols, for example, is what we provide it. It's not going to guess anything. It's going to only know that stuff. And so if we show it, for example, that from the balanced data set point of view that you were talking about just then, if we give it like 100 images of trees, and then only these two images here, one of a hot dog and one of a cup of tea, then the model will train believing that most things in the world are trees, and it will almost always assume that what it's looking at is a tree. So just keep that in mind. And so what I want to do, as I'm putting this data set together, is I want to focus on what matters. And in a way, I suppose, I want to do that by flipping that on its head and focusing on what doesn't matter. What doesn't matter? Because it's what doesn't matter that we have to vary. Let me tell you a little bit more. Let me show you a little bit more. We'll jump into the GitHub repo, into the Jupyter Notebook. Inside of the Jupyter Notebook, we've got images of tree, hot dog, and tea. And then there's an original folder in there. If we dive into that, then we've got a whole set of images. And what I've done here is important, and we'll dig through why this is important. But what I've done here is I've taken photographs using my phone. I've taken photographs of these images that I've printed out. Could I have taken the graphic here? Absolutely, I could have done. But we'll talk why that might not be so useful for the particular kind of solution that we're trying to put together in just a moment. Let's just click on, let's find one. Let's find T, because it's my favorite, and click on T number 10. So here is a photograph of this piece of paper, and we're going to use this to compile the data set together, along with photographs of the others as well. From Safdar's point, I've got an equal number of photographs for all of them. So take a look at this. Does it look like a cup of tea? Well, maybe, maybe not. But it looks like the image that we're trying to get. It looks like that icon. And what's important for me is that we have to basically focus on what doesn't matter. So let's I've got some white space over here. What does not matter about this image? So what doesn't matter is, I guess, the position of this cup in this image. That doesn't matter. It could be anywhere in this image and it would still be an image of this cup. The similar icons for me to draw here, but the size of the cup doesn't matter. The rotation of the cup doesn't matter. And what I mean by all of these things is I still want to recognize it no matter what these values are that we're talking about. The size, the position, the rotation of the cup. Other things that don't matter is the fact that this area here actually isn't pure white like the sheet of paper. And at the same vein, this blackness here inside of the image isn't quite perfect either. Also, there is a little bit of discrepancy between the coloration that we have up in this corner up here. Oops, I've pressed the wrong button there. The coloration that we have up in the top corner here to the down here, it's all subtly different because this is an actual photograph. So if I just took the actual PDF value and just took a screenshot from that, it would be pristine, not that one, but it'd be pristine and perfect, and unlike what I'm looking for in the real world. So I've taken this image with my camera on my phone, because ultimately, as I keep saying, we're going to be building an image recognition classifier from the data that we're capturing on the actual phone itself. So none of this stuff matters. And so if none of it matters, we have an important step. We need to randomize everything that we can from the stuff that doesn't matter. Now, if you look in the rest of these images, and if I just navigate back here and go out, we'll grab another cup of tea. Which one was that? That was tea number 10. Let's go to tea 14. It is slightly different. Let me go between the two. See, it changes. It goes, it's a bit different. And so what we're doing as we're giving these to the model to train, we're telling it what's important is the thing that's always the same, the shape of this cup. What isn't important is the shadows or the position or the rotation or anything like that. And so that's why we've got multiple images and not just one of the cup of tea. In this case, we don't have a lot. I think we've got, what, 24 images for each of the different objects that we have. And for machine learning terminology, that's different classes that we have. So we have 3 classes in this. We've got the hot dog, we've got the tea, and we've got the tree. And those 3 classes are going to be what we train our model with. And we've got 24 images in each case. It's not a lot, but for this demonstration, I think it works. I think it works fine. And in each case, they've been taken with a handheld camera. So if you want to follow along and build your own, if you want to do your own with your own data set, then find 2 or 3 or 4 simple images. If they can be on like this controlled environment of being on the piece of paper, then I think that actually helps quite a lot in this particular case. We are going to expand beyond this when we build more, but then use your phone that you'll be using for the rest of this project. If it's a camera phone, if it's not a camera phone, you're using a webcam, use a webcam, whatever it is that you'll be using that can be linked up essentially to a web browser, so the web browser can use it in the code that we write, HTML5 code that we write. Use that camera so that we're training with the data that the algorithm will ultimately recognize eventually. So that's what we're going to do. So what remains to do here is to start taking this data set that we've got and wrapping it up such that we're ready to train. So we've done a bunch of it already, and I didn't want to sit here taking literally 70 or 80 photographs and making you watch me take them. So that's why I've got these here already. If you want to take them, then you can take your own. You see the pattern here. Little tip: make them square if you can. It'll just sort of help generally, but it's not a major issue. We can talk about why. If you've got questions on this, then please throw them into the comments, and we can talk about the data sets that you want to do in this space as well. Elijah's back in the chat, which I'm very happy to see. So hopefully you saw Elijah at the beginning of this session. Whilst we're not doing a specific tree algorithm to look at different trees, you are absolutely the inspiration for one of the symbols in our data set being a tree. So thank you. And look, we have prizes to give away in this session. So we have 2 prizes, and I wanted to make sure that you were back because, Elijah, thank you for your suggestion. One of the prizes is going to you. And so we have these hats to give away. It's amazing. It's a little bit random, but we've got hats to give away. Maybe I can find a picture of one of them. They're Deep Racer hats, which AWS has very kindly offered to give away as prizes. So one of these, Elijah, is going to wing its way to you. They promised to send it anywhere in the world, and so one of them is coming to Kenya. So somehow we'll get some details from you so that we can make sure we can get that shipped out to you. Elijah, if you reach out to me on LinkedIn is the easiest way. Let us know in the chat if you don't have LinkedIn or if you're not a member of LinkedIn, and we'll figure out a way of doing it otherwise. Thank you for that. We've got one more hat to give away in this session, so I don't know, we'll have to come up with a way of giving that away. All right, let's throw this over here. What I want to do now is to look at how we can prepare this data set for machine learning. Machine learning is going to come in full force next week. We're going to be training models. We need to get our data set ready. I need you to get your data sets ready for next week as well, especially if you're using a different kind of a different kind of image. But I will get this data set ready here. I'll push it up into GitHub, and so you'll have access to that as well. And so the way I'm going to do that is through the Sagemaker Notebook. You don't have to do this inside of the Sagemaker Notebook. I'm coding it in Python. I'm doing it in here mostly so I can use that aspect of SageMaker where I can share the data, share the code with you. So let's jump back to the episode 2 level in here. And I'm going to go ahead and create a new notebook just so that we can whack the code in there. I'm just going to create a Python 3, I think, notebook, because we're not going to do anything crazy in this, but we're just going to start putting together the file format that we need to train. So what we're going to do here is we're going to package this data up and make it available to SageMaker so we can use the SageMaker image classification algorithm to train our model. And obviously having all kinds of problems. You saw connection failed, but now it's back. Let's just test that it's running okay. I'm going to do the old print hello. Let's build something. Shift enter on that. Yes, it is working. So that's all good. So what we're going to do here is we're going to put together the file format that we need, the manifest file format that we need in order to be able to give this to SageMaker. Let's just jump to the Blackboard so I can be a little bit clearer about that. So ultimately, we have our data, and we need to get it into SageMaker to do our training, which we're going to do in full force next week. This data over here at the moment, there's a whole bunch of images, as we saw, and pretty much that's all we've got. There's a whole bunch of images, some of the cup of tea, some of the tree, some of the hot dog. And what we need to do, as Safdar was mentioning before, we need to label the data, but we also need to put it in a location which is accessible by a SageMaker. And the location for data inside of S3, in almost all cases, apart from when it's not, is S3. So we're going to put it into an S3 bucket. Ultimately, maybe we'll get to that today. And inside of this S3 bucket, we need to have all of these images needs to be in there, of course. But we also need to have a file, or maybe two, which is a file of labels. So it's basically saying each one of these images will sit in the same bucket, but it'll say, okay, well, this one is a cup of tea and this one is a tree, et cetera, as it goes through the data set. So we need all of that. And then all of that then, all of this data then gets provided to SageMaker so that it can then spit out our model. Okay, hopefully that makes sense. So what do we need to do right now is basically we need to concentrate on this part here. We need a file with the labels in it so that SageMaker knows what it's doing. And so I'm going to create that through Python here. Now, this isn't specifically fancy machine learning coding or anything like that. This is just pushing data through Python. If you've got a better way to do this, then please let me know. But I'm just literally going to be compiling strings together and getting this working. So let's take a look. How can we do this? I've been playing around with this before. Essentially, it is just pushing code around. So I'm going to create a list called classes, and in this classes list, I'm going to have a tree, and I'm going to have hot dog, and these are just strings, right? This is nothing fancy. And then T. Shift enter on that, so I've got that defined. Those are the three different classes that we're going to make this data set for. I'm going to put together a list object. This is just Python coding. I'm just putting a list object together to hold our training data as we are spitting it out. So I'm going to say train LST. So an LST is the file format. It's the name of the file that we're looking for. And so I'm just going to create an empty list, but I'm also going to create a validation list as well. So when we're training with SageMaker image classification, this the algorithm takes training data. It also takes validation data. Again, as we saw previously in the previous session, we can use that validation data to see how well the model is training. And so let's define those. Those are empty lists ready for us to put some data into. Now let's start bashing around on code here. And so this is going to be almost Python 101. So let's say for C in, and then we're going to say range len, and I'll explain why in a minute. Len classes. Right. So basically what we've done here is we're starting a loop. We're going to loop through basically for each one of our classes, but we're not looping through class. We could do that. We're not looping through the classes and bringing the string out. We're actually bringing an integer value out, which tells us which position we're in. Let's look at that. So if I say print C and just run that, then I get 0, 1, and 2. So for each of the positions in our class list here, we've got 0, we've got 1, and we've got 2. Okay, so what we can then do is use that in a number of different ways, and we'll see. Maybe I should talk to you about the file format that we're looking for here. So the file format we're looking for here, I'll just put it out in text format here. We're looking for something like this, an ID for the value that we're passing into SageMaker, then a class, and then a image path. So that's the format that we're looking for: ID, class, image path, with tabs in between, by the way. So it'll look like something like this: ID 0 for the first thing, ID 0 because this is an image of a tree, and then it will be path to image tree. There we go, tree 0, for example. The next one will be ID number 1. It might be class 1, and you get the point. That'll be to the next one. So literally all I'm trying to do here is just programmatically build up this this kind of list. I could type this out by hand, but it'd be incredibly boring. And I prefer trying to automate some of this stuff through Python, because then it's kind of reusable, and you'll be able to use some of this code if you're trying to do your own different project. And so we've got this looping through the 3 different classes. If we were to say that what I want to do is print out the class with C, then it'll print out each of those classes: tree, hot dog, and T. So we've got access to that throughout this loop. So I don't want to just print them out. Let's do something slightly more exciting than that. So in each case, in the files that we have, let's just go back to the files and have a look at the files we've got here in original. We've got hot dog -0, hot dog -1. So we've got 0 all the way through to 23. So we've got 24 of these things. So we've got those access available to us. Again, we're just bashing around with code here. So if I say for I in range, and we're just doing another one of these in ranges again, but this time we're going to say from 0 to 24, or is it 23 that we want? So we can say print I. We're actually going to, that will actually then 3 times print out a list from 0 to 23. So let's make it a little bit more fancy than that. I want to introduce you to string formatting, or a way to do string formatting in Python. So what we can do is we can put these curly braces in here and say format, open some new brackets, and then the first thing that we put in here will be inserted. So let's say that we want to put I in there, and another set of curly braces in our string, and let's say that we want to put C in there. We'll definitely change this. Let's run that, and you'll see what we've got now is 0, 0, 1, 0, goes through all of the zeros, and then it'll start counting up again from 0, 1, 2, 3, 4, and then etc., etc. So now we've got the ability, essentially. It goes all the way up to 22. So it goes from 0 to 22. So I've just got to adjust this slightly. This would have to be from 0 to 24 for each one of our images. All right. So what you see here I'm doing is I'm basically just bashing around with some Python to get it to generate lists of numbers. What I'm going to do now is I'm going to extrapolate this out. I'm going to make this a little bit more sophisticated. I'm going to get this to generate the first part anyway of our LST file that we want to add together. So so let's do this. So the first thing we want to have in that list is the ID generally coming out. Have I done this before? Yes. So what we're going to do is put into here the class, and so the class number is for us is going to be C, and then we want to have a tab is what live coding is, folks. Stay with me. And then we're going to have here the actual number that we're bringing out, which is I. And so we need to have in here the name. So we have another one here. Bear with me. And here we're going to have JPG. It all makes sense in 1 second. And here we're going to have classes. Hi. Okay, so what the heck is this doing? This is producing us a nice formatted string, which is going to basically have the class ID printed here, and it's picking that up from here. And then it's going to have the class name here, which it's picking up from here. And then it's going to have a number appended to the end, which is going to pick up from there. It's going to do that 3 times. So it'll basically list out essentially almost exactly what we want our LST file to look like. So let's do this. And was it easier than writing it out by hand? Maybe, maybe not, especially as I've got a nice error message there, index out of range, because I have put the wrong value in there. That's not an I, that's a C. So I'll run that again. There we go. So we have the first part of our LST file defined, where we want to have the label. That is actually the label right there. That's 0. It's an interesting point, actually. When we're labeling data, we're labeling it with an integer value. We're not labeling it with the actual string. We'll have to do that matchup later on in the application level. And so 0 maps to tree 0. And if we get rid of that and we scroll down, and we have class number 1 is all of our hot dogs. And then we have class number 2 is all of that. Yeah, could we have done this another way? Absolutely. We could have gone and grabbed the file listing out, but then we would have to sort of like figured out a labeling process, and you could label them by hand, whatever. We've pretty much got what we want there. What we also need on the beginning of this is the ID, the row ID, which needs to sit in front of this here. I haven't done that yet for a reason. Also, we need to split our data up between our training list and our validation list. So let's say that instead of we want to go from 0 to 24 here, we're going to go from 0 to 20, and we're going to just slice off a portion of this, which we're going to use just for our training. Safdar, if you've got other ways to do this as well, let me know. But I'm going to add this into our training list file. So instead of this print statement, I'm going to go append. And so we're now appending into our training list. So we're just taking the training list that we had at the top here, appending into that and adding in our big long string thing. And then I'm going to copy this down. Oops. I'm going to copy this down just down to here. And I'm going to go and say that I want to take the values from 20 to 24, and I want to put that into my validation list here. Okay, so now I've got, I'm not printing out to screen anymore. I'm now just creating these 2 different lists. So if we have a quick look at the validation list, let me just go insert cell below and just put that into there. Shift Enter will run that. And you can see it's a string. It's got that tab in there. But you can see a slice of our data has been taken off, and we're going to use this for our validation. Okay. So I haven't quite finished yet, of course. We need to have that ID on there. But there's also one other step that I want to take here. Now, this one depends a lot on the algorithm you're doing as to whether you actually need this or not. But I'm going to say that we do. I want to shuffle this data. So if you look at it at the moment, we've got all of the trees together, all of the hot dogs together, all of the cups of tea together. And so if we add it into the neural network to train in that order, then there's a good chance that the network as it trains is going to be sort of made slightly less accurate by the fact that all of this data is coming through in a very regimented order. So we really want to get a better training outcome, a faster training outcome, by randomizing the data that we have inside of here. So let's go ahead and do that. Let's go and import random, oops, the random library set from in Python. Let's go and insert a cell below. Let's get rid of this, push that down. And now what we're going to do is we're going to randomize those lists that we had. And it's so super simple and easy to do that in Python. So we're going to say random shuffle, which is the command, and then we're just going to pass in the name of the lists that we have. So we're going to take our training list, and we're going to do the same thing for our validation list. We're doing that now before we put the ID on it, so the ID can be appended in or prepended in just a second. So now I've just run that cell, and it should now all be shuffled. So let's insert cell below that and have a quick look at, actually, let's look at the validation list because it's shorter. And you can see now that we've got all of our data kind of randomly shuffled together. This is what we want. Now, again, we've got a small amount of data here. This is a small project, but we've got a relatively simple project to do, which is these black and white images that we've got. That's one of the reasons why I chose that, is to make it really super simple. As we build it, we don't have to have much data to play around with. But this is now randomly shuffled, both of our training list and our validation list. Okay, so now we just need to prepend onto that an ID. So let's do that an easy way, and we're going to say for I in range, and this is going to be the range of the length of, we know this already, but the length of our training list. So now we're going to generate a number for each line that we're in. And so basically now let's just go ahead and say, we're going to almost cheat here. We're going to print out a formatted string, and we're going to have a tab here and another format. What we're doing here is we're going to take that I that we've just generated, which is the line number essentially, and we're going to add on to that the line from the training list itself. All of this will become very evident if I run this. There you go. So now we've got our ID at the beginning, which is coming from this I here. Sorry, should use the technology I've got. We've got the ID at the beginning here, which is coming from this I here, which is basically counting its way through the list. We've got this ID here, this label, sorry, here. So hot dog is label 1. We can see tree is label 0. We can see T is label 2. The first 3 lines nicely and neatly show us what we've got. And you notice as well that the image numbers are all over the shop. They're all randomized. So we have a nice randomized data set there. And with this essentially is the LST file that we need. And so a super simple way to get this out would be just literally to copy and paste that. So maybe that's what we do. You could also send this out to a file using Python wizardry. Let's go and copy this and insert a cell below. We're going to do exactly the same thing, but this time is going to be for our validation list and our validation list here. Oops, Shift Enter to run that. And so now we have that out in order to. Now, why didn't I put these IDs on before? Well, because if I put those IDs on before and then shuffled it, then those IDs would have been shuffled too, and the algorithm would have seen, basically would have unshuffled everything for us as it was training with that data. So it was important to do that as that secondary step. There is our LST file, and there is our LST file. I'm super lazy here. Let's just take this. We're going to copy this. This is probably quite bad, isn't it? I'm going to copy that. Let's go back to the top level, and I think, can you just do new text file here? Actually, I don't want to be here, do I? Let's go back down to episode 2 into this layer here. I'm going to say new text file, and literally you can edit text files in a Jupyter Notebook as well. So that's worth knowing. So let's call this one train _ LST, and I'm going to call it .lst. It's just a text file. Then I'm going to click OK. And then we're going to go back and we're going to say file new. We're going to go to text file, and we're going to say val _ lst.lst. Doesn't really matter what you call it, as long as you know what it's called. Then I'm going to go back into my code here. Where was it? Now in here. I'm going to grab in this. And we've got that there. I would welcome you, once I've done this, I would welcome you to go and make that code a little better. Please, pull requests are welcome into the GitHub repository. Let's go and save that. So file save. And we'll go in here, make sure that's saved, file save. Excellent. So there you have it. What we have now is a simple data set that we have ready that we can put inside of S3, ready for training. And I think that we'll probably do that at the beginning of the session next time. We're going to bring this into S3, and then we're going to give it to SageMaker so we can start to train up this model. I want to recap now some of the things that we've just talked about and why I talked about them. Because again, we've covered some really important topics here, and maybe I didn't even stress them enough. There are some really important topics, and it's about the data set that we put together. It's about what Safdar mentioned before as well. Let's go back, bring Safdar in. If I can find my mouse. Hey, Safdar, so the important things about putting together a data set like this, making sure it's a balanced data set, as you said, making sure that you've got an equal number, or as much as you can, an equal number of the different classes that you're bringing in, especially for this kind of problem. If it's expecting to see, if the app that we are putting together could expect to see any of these objects with the same kind of frequency, then that's what we should train it on. We also looked there about the way that the data is shown in the image. So it's important, or it's useful, to actually take a picture with the device that we're going to use. So it's got the same kind of camera artifacts, same kind of noise. And we'll look to see how accurate this is next week, right, when we actually train this model. I reckon there's going to be some problems with it, but we can look to see how we can fix them up. Different angles, different sizes, and obviously I mean by that just zoom in and out. Where's the camera? There it is. Different angles, different sizes, different positions in that image space. All of that stuff doesn't matter to the algorithm, and so therefore we should vary it and randomize it as much as we can when we're putting together the data set. So in a nutshell, that's putting together a data set. And this translates over to other things too, right? This translates over to tabular data sets with just numbers and all the rest of it. But I think it's easier and more visual, I guess, if we're putting together this this visual data set that we've got here. How have the comments been, Safdar? Have we what have people been saying?
I think people are really enjoying and busy in understanding. So we do not have much of the comments right now. This means that they are completely into the the concept. And Mike, it's very interesting. And I liked something, the LST concept. So I now understand, and please correct me that. We have to tell computer, it's like a kid, when the kid is learning new stuff. You tell him this is bridge, this is tree. So I think this is the same thing which we are trying to do. So it's like a book for the computer to tell them this is a tree, this is a tree, and we are telling him the algorithm that this image is a tree, and then that image definition is in the LST file, right? So that's very interesting, actually.
Yeah, that's right. That's right. And again, just making sure that the algorithm, the student that we had, they know nothing, and I mean nothing about the subject. And so, yeah, they only know what we show them, and so it's important to be able to show them all of the elements that we want it to be able to pick up. So yeah, absolutely, we're putting together that book. So next week we'll dig into the SageMaker image classification algorithm. We'll look to see how it works, and we'll use the data set that we've created here. Now, I appreciate that at the end of this session, what have we got? We've got a bunch of images, and we've got a little bit of code. I want you to go and build your own data sets. If you can follow along with exactly the same data that we have, or you can go and build your own data sets and let us know what you've built, because I think I'd really like to see that. We'd really like to see that. Maybe we can share it as well. If you get in touch with me throughout the week, I'm more than happy to sort of showcase the work that you've done. So that would be really exciting, whether you've watched in the live stream or whether you've watched after the fact in the recording. That's going to be great. But what we've done here is super, super important, and we'll see how important it is next week as we start to do the easy bit, honestly, which is the machine learning bit. So that's it for this live stream. Thank you ever so much to everybody who's been on board with us throughout the stream. Safdar, again, likewise, thank you so much for being here. What plans for this week? Have you got any plans, or are you resting up from your road trip that was?
So I may be resting up this week actually.
You're gonna rest up, okay. Do you get much machine learning in during the week, or is this basically your machine learning fix?
No, I had couple of initiatives which we were following with few of our customers. So I had few chances of solving some customer issues and challenges.
Awesome. Because of course, Safta, we didn't say at the beginning, you are a technical account manager for Amazon Web Services. So you spend your days helping people navigate through this kind of thing and helping customers achieve brilliant things and everything that you do. So that's awesome. Thank you so much, Safta. We'll
Thank you
leave it
so much.
there. And
Thank you.
I'll look forward to seeing everybody again next week. And in the meantime, get out there and build something.
Thank you. Have a nice weekend. Bye.
Bye-bye.